continue with unit number 503, a multi-stage transistor amplifier. We discussed in earlier lecture about some important terms related with the multi-stage amplifier. The first term was gain, second frequency response, third one is bandwidth, and then gain in dB. Now we know very well the relationship between frequency and gain. The frequency and gain vachino relationship it will be related like that. When as you increase the frequency, again will be increases up to the certain limits, and it becomes constant for a while. That frequency we call as a resonance frequency. But after the resonance frequency, if you increase the frequency, the gain will be reducing because of capacitors we are using. So main important thing in transistor amplifier is a role of capacitor. So next topic, role of okay. Before start this, let's have an introduction about the capacitor. We know very well the reactance offered by the capacitor, that will be given as Xc is equal to 1 upon 2 pi Fc. 2 pi Fc. So ultimately for DC the frequency is 0, it offers the infinite reactance to DC. Infinite reactance to DC. But for AC, this Xc depends on a value of F and C. Value of F and C. So ultimately we can say that the capacitor will block DC and allow AC to pass through it, because it offers infinite reactance to the DC, so it will not allow DC to pass through it. It offers a low reactance, or we can tell that reactance is depend upon F and C. So we can say that it will allow AC to pass through it. So in transistor amplifiers, suppose we are using a simple, let's say this is a transistor. They are filtering common emitter connection. So emitter will be common terminal for input and for output. So in input we are using one capacitor. This is we call as, let's say, called as a CE. This is called, we are using one resistor over here for stabilization, and one is we are using one more capacitor in parallel with this. Let's say this is called as a CE. We know very well, we have discussed about the multi-stage transistor amplifier. So one more stage will be there. Let's say one more stage means one more transistor will be used over here. And this output means whatever the output over here, this will be given to the input of the second stage. So we require one more transistor, a capacitor over here to couple these two. That's why this is called as a CC. So ultimately we are using three capacitors in amplifier circuits. The first one is CE, that is called as the input capacitor. Second one is C, that is called as a emitter capacitor, or is also named as a bypass capacitor. It is also named as a bypass capacitor. A third one, that is CC, that is again called as a coupling capacitor. That is called as a coupling capacitor. So this is an input capacitor, bypass capacitor and coupling capacitor. So what is the role of these three capacitors? See, we know very well our input is AC. This input needs to couple with the transistor input base terminal. So for coupling our input AC to the base of transistor, we are using input capacitor. We are using input capacitor. That is first one. Again, we can say that a capacitor will block DC and allow AC. So for input, whatever the DC components present in the signals, that will be blocked by this capacitor to provide a DC isolation. So this is first purpose of the CE. Second, what is the purpose of CE? It is named as a bypass capacitor. Why? This is generally used in a parallel with emitter resistor. It is always connected in parallel with emitter resistor. Why? The reason behind it is that it offers a low reactance to the AC. It offers a low reactance to the AC. So we can say that whatever the AC signal over here, they offers a low reactance path. So they will be bypassed through this emitter capacitor. That's why it is named as a bypass capacitor. Bypass capacitor. So first one is CE, input capacitor, which is responsible for coupling our input with the it means our AC signal with the base of the transistor. Second one is emitter capacitor, that is named as a bypass capacitor, which is connected in parallel with the RE that is stand as an emitter resistor. So it offers a low reactance to AC. So AC signal will be passed through it. Third one, that is we call as a CC, that is named as a coupling capacitor. What is the purpose of it? It is similar to this one, but what is main difference between these two? It couples our input AC signal to the base of transistor. A CC will provides the coupling between two stages. Coupling between two stages. That is, let's say this is my stage 1, this is my stage 2. So it provides a coupling between. We know that this is first stage, this is second stage. We need to couple these two. For that purpose, we are using capacitor, that is known as a coupling capacitor. Again, the main purpose of this is to block DC components and allow AC components to pass to the next stage, so that it provides a DC isolation to our next stage. So this is three main capacitors are used. We know XC, that is 1/2 pi FC, which is if for the DC frequency is 0, so it offers infinite reactance to the DC, so it will not allow DC to pass through it. It offers low reactance to the AC, depends upon value of F and C. So on the purpose of this, we are having three types of capacitors. We are using a input capacitor, which is used for coupling our input to the first stage, a bypass capacitor, which is connected in parallel with the emitter resistor, which will bypass our AC signal, which is having a low reactance path. And next one is a coupling capacitor, which is used to couple the two stages, which is providing a DC isolation between two stages and a couple between two stages. So there will be a simple questions will be asked in the questions. The purpose of coupling capacitor. Purpose of coupling capacitor. The main purpose, there will be two purpose of coupling capacitor. There are main two purposes are there. The first one is to provide coupling between two stages. Coupling between two stages. That means the output of the first stage will be fed to the next stage via CC. And second, to provide DC isolation. That means whenever you block DC and allow AC, so whatever the DC components are present in the output, they will be blocked by coupling capacitor, and it will pass AC signal to the next stage. So this is purpose of this capacitor. Now, according to this, there will be three types of multi-stage amplifiers are there, depending upon the coupling we are using. First, if you will be coupled for two stages by using resistors and capacitors, then it is called as an RC coupled transistor amplifier. If you are coupled at two stage by using a resistor and capacitor, then it is called as an RC coupled amplifier, that is resistor capacitor coupling amplifier. If you couple at two stage by using transformer, that is called as a transformer coupled amplifier. And if you are not using any kind of coupling between these two, then it is called as a direct coupling. So we can say that there will be three types of multi-stage amplifiers are there. First one is if your coupling will be done by using a resistor and capacitor, that is called as a RC coupled amplifier. If your coupling is by using transformer, that is called as a transformer coupled amplifier. And if you are not using any kind of coupling between two stages, it means that output of the first stage will directly couple with the next stage, that is called as a direct coupled amplifier. Thank you.